Hi, and welcome to TEMEKO. In this video, we are going to learn how to analyze the motion of two particles when they are in dependent motion. During the video, we will use two different case examples to learn how to do this kind of analysis. Let's get started. Before jumping into the case examples, we need to first understand what is meant by dependent motion of two particles and when it can occur. We can say that the two particles are in dependent motion when the motion of one particle also affects the motion of another particle. Most often, this type of motion is presented when two particles are interconnected to each other by the cord which is wrapped around the pulley. A very good real-life example is an elevator which is interconnected to a counterweight by steel ropes that are wrapped around the pulley system, driven by an electric motor. When the elevator moves, the counterweight which is interconnected to the elevator also moves at the same time. Therefore, they are moving dependently to each other. Okay, now that we know what is meant by dependent motion of two particles, let's look at our first case example related to this kind of motion. Think about the following scenario in which we'll have two blocks named Block A and Block B that are laying on the inclined plane and which are interconnected to each other by a simple rope. To make this case simpler, let's assume that the rope is inextensible. As we earlier established, in case of dependent motion, when block A is moving, for instance, downwards along the inclined plane, this causes a corresponding movement of block B up the other incline. We can express this relation mathematically by first specifying the location of both blocks using the following position coordinates SA and SB. Then, we could write the equation for the total chord LT as follows. SA plus LCD plus SB equals LT, where LCD is the length of the chord passing over arc CD. To obtain the equation for the dependent movement relation between velocities of block A and block B, we can take the time derivative of the equation that we have just obtained by realizing that LCD and LT are remaining constants, while SA and SB are varying in time. Therefore, we finally obtain the following equation: dSA by dt plus dSB by dt equals 0, or VB equals minus VA. If we want to analyze the acceleration which either block is experiencing, we can derivate the velocity relation equation further, which yields the relation between the accelerations as follows: AB equals minus AA. Let's raise the difficulty a little bit and introduce a more complicated case scenario that is shown here. In this case, we can write the equation for the relation of the position coordinates for the two blocks as follows: 2 times SB plus H plus SA equals LT. Since LT and H also remain constant during the motion of the blocks, the two time derivatives yield for us the following equations: 2 times VB equals minus VA, 2 times AB equals minus AA. Note that when block B is moving downward, that based on the figure is the positive direction of SB, block A is moving to the negative left direction of SA, with twice the motion of block B. There is also another method to solve this scenario, which is by defining the position of block B from the center of the bottom pulley as is shown here. If we solve this example by using this other method, then we obtain the following relation equation for the position coordinates as follows: 2 times H minus SB plus H plus SA equals LT. If we then take the two time derivatives of this equation, we finally obtain the relations between the velocities and accelerations as follows: 2 times VB equals VA, 2 times AB equals AA. But wait, why are the signs the same when earlier they were opposite? A small hint: the answer can be found from how the positive directions are dictated for SA and SB. Hopefully, by watching this video, you know the definition of dependent motion of two particles. And you are also familiar on how we can analyze this kind of motion based on the case examples that we have presented. Thanks for watching and have a nice day.